Thank you, Jason. And thank you for the organizers. Some of them are here. This is really cool event. And so I feel a little bit like I'm giving a Cold War talk, but Cold War is having a tragic comeback these days. So a 20th century HPS talk can't be worse than that. So let me see. The topic is so the starting point is this famous paper by, well, famous. I mean, I think it's an important one by Lakatos Zahar back in the 70s. I thought it was an influential one because it was influential to me. But if you look at the citations, maybe, I mean, I would expect it more. So anyway, so what they are doing here is, very briefly, they are trying to make a case that it was rational for Copernicans to pick up their own theory from the start, right? So they make a case that the Copernican theory had what they call immediate support. In order to do that, they need to make a refinement of Lakatos's original methodology and have this use-novelty notion that is presented as in the form that Zahar provided around the same time. And they are trying to also counter, to refute, let's say, a charge that you find back in Kuhn's Copernican revolution, that the early Copernicans, by which I mean mostly Galilei and Kepler, they were perhaps irrational, right? That's the phrasing in picking up the theory at the beginning, right? Before any new discovery that they might been able to put forward. So there's this paper later on, and it is a thorough criticism of the first one, published in 1992. And so let me try to motivate briefly why one would ever think to go back to this controversy. I think there are plausibly three reasons. So the first one is the following. So there is a problem about Tycho's system, right? So there is a complaint that Lakatos Zahar in the beginning, they were not giving due attention to this theoretical option that was on the table back then. And in fact, I mean, the complaint is not entirely unmotivated, because if you look at the paper, they do use Tycho in order to provide their criticism of earlier alternative methodological attempts to analyze, to reconstruct the Copernican revolution. But then when they go on with their own analysis, somehow it looks like Tycho disappears, and it's not entirely clear why, right? So one thing might be, okay, so can you have their claim surviving if you go back and set straight this part of the story? Another point is the following. So if you look at this paper by Thomason, he is heavily relying on the earlier formulation of use-novelty by Zahar, which in many senses, I mean, it was an initial attempt to solve a problem. It was meant to be on the right track by Lakatosians themselves, but in many other senses, it's surely not the last word on the topic, right? There's much work having been done meanwhile, and so it might be interesting to see whether you can have, you know, a different view of the debate if you integrate Lakatos Zahar's original argument with a more updated, let's say, different and more effective way to account for use-novelty. So that's another thing. And also, to the best of my knowledge, there is no reply to Thomason, right? So, and Thomason does not, it does not challenge Lakatos and Zahar criticism of the other rational reconstructions of the Copernican revolution, which means that, I mean, if that's the last, suppose that's the last word, then it turns out that we have no, you know, possibly no way to resist Kuhn's charge of irrationality for the early Copernicus, right? Because that was like the best option to do that. So yes, so I would like to answer these three questions in the positive, and let's see how it works. Let me see. I'm not claiming much originality. I'm basically trying to put some different pieces together that are sparse and see whether a clearer picture comes out. Okay, so the first thing is, this is so in fact when I say it was not influential as I thought, right? In fact, there's a long story up to the present of people more or less, more or less aware of Lakatos Zahar work, and they stick to the idea that basically, Galilei and Kepler were not made, the basis for their choices were at best, limited, let's say. So here is one example, it's just one of them, but it's really a fairly widespread feeling I've discovered. So it's talking about Tycho, right? It says, first of all, it describes the system in this way. So you have Sun and Moon in orbits around the Earth, but with all of other planets moving in orbits around the Sun, right? And he goes on and says, okay, until Newton, then it seems to me that the ecosystem was clearly the best available theory, right? This is before Thomism, by the way, but you have all kinds of statements of this in this period. Now, so if you read, like for instance, this is a famous letter by Galileo to Kepler, and it says, I've been a Copernican for some years, and the reason is that I've been able to understand the causes of several natural effects, which are surely inexplicable by current theories, right? This is way before, like, Venus phases, anything, right? So they can't both be right. Right? Because surely Tycho's system was already in place, and Galilei must have known that. Okay, so here is one way to try to, it's a modest thing, but I think that we are used to describe Tycho's system as a mixture, right? So as a combination of Ptolemy and Copernicus. That's what Thomson says as well, does as well. I think that's extremely misleading, right? So it really is. What it is that it's entirely Ptolemaic, except for one thing. By which if you look at, you have this mathematical construction of, the planets orbiting the Sun while the Sun orbits the Earth. But if you look at the trajectories that are postulated by the theory, then you will see, you can prove it, that they are precisely the Ptolemaic trajectories. It's just for all planets, you have a trajectory around the Earth, which is identical with a classical deferent epicycle system, where the epicycle is the Sun, identical to the Sun's orbit around the Earth. This you can prove, right? So it means that the theory, if you look at the kind of trajectories that are postulated, you get the usual Ptolemaic story about what the planets do around the Earth, the stationary Earth. That's what you get. Of course, we know there is an important difference, and the difference being that the Sun is not behind, and it's not farther away than Mercury and Venus is placed at the center of their epicycle, right? Which is, of course, an interesting move. There's a story behind that. It's not entirely new either. It's interesting, but it's immaterial because Venus phases are irrelevant for Lakatos Zahar's argument completely, right? So there's no. This is true, and we might discuss about that when it comes to Venus phases. But for that debate, Tycho's model is nothing else than a specification of the Ptolemaic approach. So that's one reason why it would not make a difference, I think, to explicitly include that in the analysis. So the second thing that I want to do is to tentatively provide an explication of use-novelty for the purposes of the discussion. I mean, in 21st century philosophy of science, you would never ever think of doing anything like that, because the record is you will get in trouble very soon, right? But this is meant to be a 20th century philosophy talk, so let's try that. I will say that F is use-novel, right? For a theory, in case there is something else that is known, E and F follows from T and E, but not from T alone and not for E alone, right? There's going to be, of course, some contextually unchallenged assumption in order for this to work out. So the idea is the following: you have this bit of theory. If you can logically derive some piece of known evidence from some other piece of known evidence, then the second one counts as use-novel in this case, in this sense. So let me point out two things. The first one is, well, of course, this is meant not to follow from the evidence, because otherwise you have troubles. But I mean, this is just logical trickery. It's not really very interesting. I mean, this is of course very much in line with John's work on this topic. It's not meant to be much more than one way to push out. I don't know whether it's successful, but for our purposes, I think it's good enough. It's good enough. So example, a non-Copernican example, E is Kepler's first law. Let's take that as a fact, as Newton might have done. T is Newton's theory. You can derive the second law from the first. And in that case, in that sense, you get the confirmation from the second, according to this story. Okay. There's an interesting analogy with cross-validation in statistical settings. So you have I mean, of course, this is not logical relationships, because there's uncertainty in there. But what happens is that you have a data set, you divide it up like in two halves, and then you fix the parameters with one half, and then you test the model with the other half of the data, very roughly. And I think it's analog with what I'm trying to capture here with this, in this case, where we apply the usual elementary logic philosophy of science tools, let's say. Okay, so this is, of course, this is very different from what you find originally in Zahar, and this is very different from what you find in Lakatos Zahar original Copernicus paper, and it's very different from what Thomason is relying on in his criticism, right? Okay, so let's try that out. So they mention this Copernican rough model. I will spell it out like that, like this. So there are planets. The moon is not one of them. They orbit the sun in circles ranked by increasingly long orbital periods. I mean, I think that is basically legitimate, because this point about their order, their ranking is very explicitly mentioned by Copernicus. He says it's like common knowledge in the debate, and I mean it's a relevant part. I think it's a relevant part of the model itself, right? So let's try to see what would be the corresponding core model for a Ptolemaic. So it would be the planets. Now we have moon and sun included. They orbit the Earth in combinations of circular motions, presumably not too many of them, I don't know. And the ranking about increasing from increasingly long orbital periods is still meant to be there, although there are a few, I mean, details which complicate a little bit that point. But let me go on here. It doesn't. I think it's not a problem. So I am going to provide you some examples. I'm just drawing them from either Lakatos Zahar and Thomason himself, right? It's a few cases in which you do have this use-novelty confirming effect for MC, and you don't have that for NP on the basis of this tentative characterization. So first of all, there are planets. other than the Earth, the Moon and the Sun. You put that together with MC, and you get that there are retrogressions, right? That's a matter of geometry, because there will be cases where the Earth is like overcoming external planets or being overcome by internal planets, and that's where retrogressions comes out politically, right? It's a matter of logical implication. This is mentioned by Lakatos Zahar. It's the first one that they mention. Of course, these F, the retrogressions, they do follow from the full Ptolemaic ecosystem. That's the Gleanian thing, right? But E is then superfluous though, right? Because the model already says that there are planets. Of course, it's part of the model. You don't need E in order to derive that. But F does not follow from this statement and the Ptolemaic core model. So in this sense, it would not be use-novel for Ptolemy, and it would be use-novel for Copernicus. I have a list of those. I mean, they are very interesting in themselves, but I mean, it's mostly a matter of focusing a little bit, using a bit of geometry. So, for instance, if you have a planet whose period is shorter than the Earth's, you put it together with the Copernican basic model, and you end up with the conclusion that the planet never goes in opposition, right? It's an internal planet. You never see it in the middle of the sky, or the night sky, in the middle of the night, opposite to the sun, right? That's limited elongation of internal planets. That's already something that you get for free by this idea, together with just pointing out something that you know, right? So the Venus period, as referred to the sun, is going to be shorter than the Earth's, shorter than 1 year, right? So there are other things. This is a bit more subtle, right? So if you have a planet such that the orbital period is less than 1/2 of the Earth, then you can fairly easily show that there will be more than one retrogression for that planet in a year, right? And this one is something that you know. Again, it's meant to be, for a Copernican, it's meant to be basically implied by already available data, right? And again, you can't have this conclusion from this premise, this known premise, by just the Ptolemaic model. Of course, this is accounted for by the full models, right? When they are specified on the basis of the data. That's the idea. There's a list of them, right? So for instance, if you have a planet such that the orbital period is larger than the Earth's orbital period, then if you apply the Copernican model, you get that retrogressions will precisely occur at opposition, right? That's what you get. The reason is that in that case, for the external planet, the retrogression happens when the Earth is overcoming, because it's moving faster, the external planet. When that happens, of course, I mean, the planet and the sun are opposite to each other, right? It's really, you just have to think about it. It's really qualitative implications. So you can also show that for external planets in the Copernican framework, you're expecting less than one retrogression a year, just on the basis of the rough model, and so on and so forth. There's a few of them. This is very nice. This is in Copernicus and in Thomason. It's not in Lakatos Zahar, as far as I can say. So if you have two external planets, such that one of them is, it has a longer period than the other, then you are going to derive from this model that retrogressions are relatively more frequent for the more external one than for the more internal one. I mean, the farther one as compared to the closest one, both of them are external. And also you can derive that from the same premise. You can also derive that the arc, the retrograde arc, is larger for the closest one than for the farthest one. Right? Okay, so all of these cases, on the basis of my proposal, they turn out to be use-novel for Copernicus and not for Ptolemy. Right? So they would fit the general strategy of Lakatos Zahar. Okay, so let me now give a little bit of historical sort of support to this story, to try to, let's say, make a connection between this explication and what happened back then. So first of all, this is Clavius. Clavius was probably the most influential Ptolemaic astronomer by the time. And this is something that he writes towards the end of the 16th century. So he says that Copernicus should have succeeded in saving the phenomenon is not at all surprising. Why is that not surprising? Well, because he was taught by the existing models, let's say, all the data that were needed, right? So he knew the times, the magnitudes, and so on and so forth about the appearances, the phenomena. And he was ingenious, right? He was a very clever man. And so that's how he came up with a method of saving the appearances. And then there is an analogy, it's an important analogy. He says, it's just like when we know that there is a certain conclusion that we want to get, right? And surely we can construct a, this is Aristotelian logic, a chain of syllogism which derive that conclusion from false premises, right? You can always do that. It's trivial, right? So that's Clavius' assessment of the situation by this time. Now, first of all, Clavius knows duet, right? But I want to make a case that this is a misapplication of this point, right? Because that's not the case for Copernicus. And Copernicus knew that. They knew that, right? So here is another way to spell out this piece of methodology that was appreciated by other people by the time. So this is in Descartes, sometime later. And he says, it is true there are many effects to which one can easily fit diverse causes one for each. Still, it's not equally easy to fit one and the same cause to several distinct effects unless it is actually the true cause from which they derive, right? So there's another passage by Kepler, I didn't put it in the slides, where he says, what you find in Copernicus, this idea of revealing new logical connections between available data, right? This pattern is something that, in his words, in Kepler's words, truth permits, right? That's something that arises when you have something probably true in your hands. And of course, that was precisely what Copernicus said, right? All these phenomena proceed from the same cause. I mean, this cause language of this period, we should not take it in terms of our own contemporary comprehension of understanding of causation. This is just basically in this language, which is a very traditional one. When they talk about causes, they are talking about what we would probably rephrase like successful explanation. I mean, non-ad hoc explanation, right? That's what they mean. Something more than just saving the phenomena, right? It's something more than just saving the phenomena. It is something that truth allows for, in their words. And that's what Copernicus saw in the theory. And the point then is the following. So allegedly use-novel evidence, just like ordinary successful predictions, there are other places in this period where you have these predictivist statements very clear, like Huygens. So what use-novel evidence is telling us about is the theory's epistemic value, not how clever the theorist was. That what, in this sense, Clavius would be wrong, right? It might be the case that Copernicus was very clever, but that's not the reason why he got these results. Okay. Well, I'm pretty much done, which I suppose it's good news, is it? Maybe even too good. I don't know.
Over 5 minutes.
So anyway, first of all, I think that you can make a case that Lakatos Zahar's point survives if you look more closely to the Tychus case, and you devote. You tell a story about that. You can do that, I think. Second, yes, if you have a more developed analysis of the accommodation prediction thinking, especially one where all these psychology, historical factors are somehow screened off, which is a big problem in these debates back then. So then this does help indicating their original verdicts. And so yes, we do have, I think, after all, a chance to resist Kuhn's charge of irrationality on early Copernicans. Let me zoom out a little bit and also attach a couple of additional remarks. So the first one, I mean, in principle, you can try to check out for this immediate support, tell the same story. As I said, it's not terribly original. For instance, apply that to Newton's Principia, right? And if that works out, then the question would be, is this a pattern of progress in the history of science? I'm mentioning Stefan's lecture yesterday, right? So he said we want to look for patterns of progress more than just cases, right? Maybe we can do that. I don't know. The second point is that I dare to claim that this story can be made coherent with a Bayesian view of scientific reasoning and rationality. I mean, it doesn't have to, but I think you can make a plausible connection, not just a entirely contingent connection with a Bayesian view. Of course, you would have to have a Bayesian story about all evidence, because that's the point, right? So this is actually all evidence in the relevant sense in this debate. I'm not giving any specific proposal about that. There are several on the market, and some of them may work better than others. But I just want to flag that, contrary to very strong inclinations of Lakatos and other opinions, I don't think there is any crucial conflict on that level. Yeah, that's it. Thank you.